Hi everyone, welcome on this new stream on the Module17 board. So as a reminder, we are in the process of developing the revision 1.0, which is a slight increase from the 0.1e, which is the latest as of now, in which we fix a few bugs here and there and mainly add a compatibility with a possible case later on. Okay, I don't know if people are already listening or not. Let's start some music. And see how, oh, it's maybe a bit too loud. Hi Steve, you're listening, great, welcome. Okay, so I think nothing changed since last time. What did I do last time? Maybe a few things, minor things. Yeah, I think mostly what I did was modify the schematics a bit so that we could export them in PDF. So I don't know if it was already like this in the previous episode. I didn't check, but I think I just changed a few things in the schematic, renamed all the components, exported the PDF, and also, yeah, I remembered about the music. Don't worry, Foche. So yeah, okay, so just checking. Hi, I don't know what's your name. IZ3MEZ. Welcome. So yeah, renamed all the components so now it's the style I prefer. It's all the components start with a multiple of 100 depending on the page on which they are. Which means that if you see a component on the board R211, for example, you know that you will find it on the second page of the schematic. I prefer to do it this way, and on Module 17, the components numbered aren't printed on the board anyway, so the number definitely doesn't change anything to what we do. Maybe the biggest change from last time is this. So I added a few 3D models, a very crude 3D model for the 12-volt input jack, and I downloaded the 3D model from the manufacturer for the volume potentiometer. Thing is, for this one, I really have no idea what the license is for this one. So basically we can't include it, I think, in the GitHub repository. Otherwise we might get into some trouble. So the thing is, we have a folder in the GitHub repository with a file containing all the links to the various step files that you can download, then place in that folder, and it will automatically display them on the board. So yeah, I think that's pretty much it. Hi Pierre. So I think maybe the first thing we should try to do now, we might have small issue with the power supply actually. So currently you have the 12-volt input, which is stepped down to 5 volt, and then this 5 volt it's stepped down to 5 volt using a DC-DC converter, which works at 800 kilohertz, and then it's stepped down to 3 volts or 3.3, I think, using LDO. So this one is much quieter, but this one has some switching noise. But the problem is that the 5 volt is also, so this 5 volt goes through a ferrite bead and then some decoupling capacitors to become the VAA. So VAA and plus 5V are both 5 volts, but VAA is slightly filtered. So if we go have a look in the audio and filter page, we see that this one is powered by the VAA, so it's 5 volt slightly filtered. And then we have the power amplifier, audio power amplifier, which is directly from the 5 volt. The problem is that this one is gonna have some switching noise on it, which I don't like, and maybe mostly the problem with VAA is that basically a ferrite bead is not enough to filter this switching noise. Switching noise is at 800 kilohertz, but if you have a look at ferrite beads, usually they work at much higher frequencies. So I think, yeah, we have a manufacturer part number, so let's have a look at this one to show you what I mean. Let's open the manufacturer's website. Oh, printer friendly datasheet, great. So this is what we are talking about. VAA is gonna supply, I think, it's not supplying much. It's supplying mostly the audio amplifier here. And I think that's pretty much it. Or maybe it's also, no, I think it's also powering baseband, yeah. The baseband amplifiers are powered via VAA2. But that means that, yeah, this doesn't consume much, so it's not gonna consume, I think it's like, yeah, maybe 10 milliamps, something like that, so very little current. So it's gonna be like between those two curves. And you see that the graph starts at 1 megahertz, and at 1 megahertz, impedance is extremely low. Oh, and can I open this? No, it doesn't want to. Okay, maybe I can just zoom in. Yeah. Basically, you are like at about 0 ohms. It's not gonna filter much. Ferrite beads are usually used for more of the RF domain. You can see that at 100 megahertz, yeah, it's about where it peaks without any currents, and it's representing 600 ohms load, so quite a heavy, it's very high impedance, so it's gonna block that frequencies. But also you can go much deeper into the ferrite theory, because you can see that it's not always resistive. At first it's behaving like an inductor basically, and then it behaves like a resistor. Anyway, that's way more than we need to know. Basically, this isn't filtering enough the low frequency noise. Sadly, I don't have any module 17 that I can use to experiment and decide on whether we have to change things or not. I've heard that I've been told that we can hear the switching noise slightly in the audio frequencies. So I don't really know. Maybe what we could do is place LC filter. Let's see. So what we could actually do is filter out with ferrite beads the power supply to the MCU, because this one, so the MCU is working, I don't know what's the maximum frequency of this one, but let's say it's in the megahertz, hundreds of megahertz, maybe, no, sorry, tens of megahertz range, maybe a bit more. So this might generate some very high frequency noise on the bus, on the voltage bus. So we could put a ferrite before that one, so that the noise that it generates doesn't propagate back to the rest of the system. But for the analog rails and so on, yeah, just like you say, Pierre, it's gonna be ferrite with gaps. LC filter, basically. It doesn't get any better than that. Of course, RC filters is not feasible because we can't add a resistor in the path of the power supply. It's not gonna work. So yeah, maybe, let me think. I guess this one is the same. Yeah, it's always the same ferrite bead. So, okay, I think ferrite, we do need a few ferrite beads on the board. It's never gonna hurt, but we need to place them at specific places. I think one should be needed here, between the computer and the board. If you filter the 5V output, the other 5V will already be clean. Yes, yes, that's true. But we need to pay attention that if we put a filter in the path of in high current path, we need to design the filter more carefully. But I think it would be better anyway to do this, because if we don't do that, then so basically, where can the noise get into the audio output or input? Basically, inputs, I don't think it can, because we don't have any 5V in the input path. We have in the output we have 5V on the filtering amplifier and the power amplifier, and so ideally, we would filter the 5V for all of this. This one is gonna be the one consuming the most current, and it's not gonna be that much, I think. It's up to 3 watts. If it's driving a differential load, but it's in single-ended mode, which means that it's gonna have quarter of the power, so 0.75 watts. Except that maybe we should, I don't know what efficiency it is. Maybe let's see. Maybe they do give maximum current. Yeah, this one is up to 3 watts. I don't think we are gonna ever reach 3 watts though. Do they have any efficiency curve or something like that? Output power. No, this is distortion. Oh, they do have power supply rejection level, power supply rejection ratio, which is interesting. It's not that high actually. I would like to know. Oh, okay. So in the worst case, power dissipation would be the inefficient part of the power consumption. In VDD equal to 5V, in the worst case, we have we would have about 2V out and 2 watts out, a bit more, and 1 watt dissipated as heat, so 60%. efficiency, let's say. So that means that we have 0.75 watts with an efficiency of 60%, which is 1.25 on the inputs, which means we have like less than 300 milliamps. It's not much actually, so we can clearly do filtering, LC filter at some point right after the 5 volt outputs. Which cutoff frequency though? I don't know. Okay, let's deal with the ferrite beads first. So I said I want to add ferrite beads by the USB plug. So that would be here. Let's just check also the maximum current for this ferrite bead. If I don't do that, it might get me in trouble. Oh, it's right here. 2 amps. A max resistance of 0.1 ohm. Okay. I think it's gonna be enough. Yeah. So we don't need to worry too much. Which means that this way it's okay. So it's the goal of this one is twofold. First, if we have some noise coming from the USB-C connector, it could be a charger or a computer, I don't know. It's gonna prevent this noise from propagating in or out of the board, basically. We won't introduce noise in the computer, and the computer won't introduce noise in the board. Well, when I say won't introduce noise, it will, but we just try to attenuate it. I'm also gonna add maybe no, it's connectors here. So in 12 volts, should we add it here or somewhere else? Now let's try to add it here. Oh, we do have one here actually, but we have a GPIO. What? Oh yeah, it's turned off the power. Yeah, I remember this one. So we have a ferrite bead here to prevent the noise coming in and out here. It's great. Just gonna, okay, I think I'll just move it backward right here. And move this on the right a bit. Like this. Perfect. Okay. Okay, so ferrite beads, I think we are maybe not necessarily done yet. Should I try, maybe I will just add one more for VDD. VBAT, I don't think we have VBAT going anywhere, do we? I think it's alone in its net. Let me check here. Which pin is it? Sorry. Oh, pin 1. That's easy. Yeah, no, it's not going anywhere. Okay, so let's just remove this. It's not needed. This is not connected. So I think this is the decoupling capacitors for the... oh, this is all over the place. For the MCU pins, we have 4 and we have... wait, what? Hey, we are missing some decoupling capacitors, I think. Yeah, okay, let's... this is gonna be VDD MC... hey, what's going on? Oh, okay. VDD MCU. Like this, and we are gonna add it here. This way, okay. So we have 4 pins, so we need 4 sets of decoupling capacitors. All right. Okay. It needs a lot of place. There are a lot of capacitors. Okay, so we have basically one set of 110 nanofarad per pin and 1 micro for the for all the pins. Basically, we don't need more than 1 times 1 micro. It's quite a lot already. Okay, MCU VDD, and so MCU VDD is gonna be connected to VDD via a ferrite bead. So let me just copy paste it. Like this, perfect. Now these, maybe we don't want ferrite beads for those, I don't know. So I have no idea what is the best value to use for the filter. I think some part of it is gonna have to be done via trial and error, basically. We could also reuse, we know we have a 22 microfarad pin, capacitor here. Let me see. Let's just take a calculator because I'm lazy. Basically, this is the design that we are going to use. Oh, that's quite a lot already. What do we have? Do we already have inductors? We have 10 micro, but this is not one we can reuse easily because it's very big one for high currents. I don't think we have any other inductor anywhere. I think we need to. We don't. If we put it too low, the cutoff frequency, then we have the risk of having 5 volts fluctuating, which is not what we want. It should still be quite responsive to current in rush currents, let's say, for the various components and mostly the power amplifier. So I'll take quite a bit of clearance from the 8 kHz that we will use as the output frequency, audio output frequency. I think if we take like about this is quite alright. So let's put this on the side, and from here let's put this, and we are gonna say it's 5. That's not this footprint we want just plain footprint. Let's reuse the same PKL library. that was already used in the project. So what is dipole? Okay. So I think this, all right. I think it's all 0603, no? Yeah, all 0603. Manufacturer part number. Let me just check. What did I say for the currents? We said that we would have about 250 milliamps just for the power supply, but we also have, of course, the MCU and all of this. So let's say it should be about 1 amp. I think this is feasible. Let me just check on the resellers' websites if we do find this easily. Just to be sure that I don't ask like anything silly. Inductors, fixed inductors. Let me show you the screen. Okay, so we have like 5 micros. I don't even know if 5 is it like standard value? Yeah, close enough. In stock. Oh. Well, okay. Oh yeah, it looks like. Oh yeah, we need to pick the to tell it the footprint, the size, which would be. Hey, wait, what? Really? Oh, dang. Looks like 5 micros is way more than I thought. Okay. Yeah, 4.7. Okay. Makes more sense. Saturation current. Looks like saturation current is lower than expected. So basically saturation current means that it's gonna lose its inductance as soon as it's gonna reach this current, which we don't want. Basically, it means that if we draw more than the saturation current, the filter stops working, basically. It means that maybe we should take a lower inductance, I think. So, like if we take 1.8, for example, or 2.2, what do we have? Okay, I'm gonna think about that a bit more off stream, I think. But maybe we need a larger inductor, I think. I just want to see like 08, 05. Oh yeah, okay. Yeah, okay. We will probably go up to 0605, 0805 for this one. Yeah, twice is maybe conservative, but yeah, of course it needs to be able to pass more than what it will be used for. Yeah, I think this is about all right. Maybe 10 micro, no, it's 5. Or it's gonna be lower, I don't know. I'm gonna think about that more in depth later on. This is gonna come here. Yeah, not less than 1.5 for future proofing. Yeah, well, future proofing. I mean, this board is not gonna suddenly draw twice the amount of currents. Definitely not. Maybe future design is gonna consume more, and then we would have to think about that. Should I add one more inductor? In capacitor, I don't know, we already have this one here, we have the diode in between. I think this is alright. Okay, do we keep these? I don't know. Doesn't hurt. I mean, okay, yeah, I think I'm gonna keep it here like this. Yes, I could find that the amplifier is having some peaks that are a bit high. Yes, I could definitely, you're right. Thing is, we don't really have any way to measure the current consumption, I think. Trying to think about if I should try to add a shunt something, put a jumper here basically in the 5-volt rail so that we can open it up, put an amp meter and measure the current consumption. This would be interesting. Is YouTube turning down the music? Yes, it is. I hate it. All right, here. Do we have like jumper? Yeah. Jumper bridged. Yes, like this. So this one is going to be used to measure current consumption if needed. So anyway, so even though we are developing the version 1, I do believe that we are going to have a v0.99, something like that, just before releasing the files to the public. This version is going to allow us to check, like, for example, okay, is this filter correct? Do we need to change the values? And if we do need to change the values, we can do that, test on our board, modify it in the files, and we won't have to rerun a full production batch, which can quickly get annoying and expensive, and I don't know what I would do is 15 Module17s. I can give them away, but I only know that many people. Okay. Do we say it's good enough like this? I think. So let's save it, export. Yeah, I guess we would want to test. So if you want just a module 17, the LilyGo guys are producing a few batches here and there of v0.1e, which is the current latest version, and it goes for a bit less than 50 euros. So I don't know how that would be internationalized. So that will allow you to buy just one. Otherwise, you can still produce 5 of them, order them, receive them, but you have to have 4 friends, let's say. 75 Canadian, yeah, I guess. That would be about that, I think. Or you can wait for the V1 to be released. I think once we have the V1 working, LilyGo will switch to V1 too. So you will be able to buy the one from them, I think, I expect it. But yeah, maybe we will have a few boards here and there, which will be leftovers from testing the design, and we could share them. By the way, while I'm at it, I don't know how many people are listening. Yeah, 2 people, it's not much, but maybe if you look at the replay, I don't know. We will be in Pacificon in October, later this month, so I think it's from the 20th to 22nd of October. We will be, but anyway, we will be in Pacificon with the European part of the team. Is gonna be there too, so if you are around or were hesitating to go there, just please do come, say hello. It would be very nice to see you all. We've already been in, I've already been in Friedrichshafen and Tokyo, and it was very nice to see people so dedicated to M17. And yeah, I really look forward to see the all the people on this continent, the American continent, let's say. So yeah. Anyway, that was a bit of advertisement on where we will be if you want to go check what we do and see us. Okay, PDF is done. Do we have all the footprints? I think. Oh, not for this one. I think I will just, for this one, I will just use like pin header. This. Yeah, this is enough. No need to go S&D stuff, it's just more annoying than anything else at some point, and we already have things going through the board all over the place, so no need for that. Okay. Save, re-export the PDF. Go to the PCB, import the changes. Let's see what it does. Yeah, of course, move that. Oops, here. Okay. Let's add the schematic on the other screen so that I see what I'm dealing with. Okay. Okay. Yeah, so we still have the power supply parts to fit in here. And before trying to fit it, I think I'm just gonna try to route everything from here, going up to the MCU, see how it goes with the MCU around there, and see if I really can cram it here, as I think I will. This will go probably in the power supply or wherever it's best. Oh yeah. the capacitors. Okay. This one doesn't need to be that close to the MCU. This one, does it have? Okay, let's find it. Yeah, a 100 nano friend. Those two, let's find them. Yeah, like this, great. PDDA. Like this. Okay, perfect. So we have paired them and placed them near the power supply pins. This one will have to go around there. This one around the MCU, and this one it's the inductor for the filtering, so let's put it here. This one is gonna go here. So test points, we have lots of them, and this is yeah, okay. We have text labels and stuff like that that we will have to place back on the board later on. Let's gather all the test points and texts and all the stuff that have to be redistributed on the board. Okay. Oh, I don't remember how much is this distance. Okay, yeah, 2.5 millimeters. Okay. So if I remember correctly, we had those protrude a bit from the face that might go on the side, but we have to pay attention that if it this one has to be as close as possible to face that we are gonna add, so it has to protrude by at least 1.4, otherwise we might have troubles putting the cable in. Hi Andy, how are you doing? And hi Dan in SD, I don't know who you are. Hello, welcome. Okay, so speaker mute, this is gonna be second layer signal. It's not very important, very high speed. As always, we will just start routing around slowly but surely, around about what we need, and at some point we will have to decide on if we move things a bit more, adjust position of a few tracks and vias and stuff like that, just like we did for OpenHT basically. What is this one? Oh, just a test point. We done. Yeah, okay. Didn't we place a plane on the first layer for the ground? I don't remember. Let's do it now. This, and all of a sudden we don't have that many how do they call it, lines, rat's nest, sorry, rat's nest. I don't know what rats have to do with all this, but here they are. Speaker output. Could we maybe put it closer to here? Oh, it's not connected. Is anyone using M17 in the States? Yes! There are plenty of people in the States using M17. So many people using M17 in the States that we go to Pacifican. So that's to say. So the plus 5 volt is gonna come from the third layer, which is gonna be dedicated to power supply. So I'm gonna write that later on. Those, it's easy to do. Let's do it like this. This is ground, so it's gonna stay right like this. VDD, great. LED signals. I'm gonna go to the MCU. So basically we don't have many more signals to route around here. Oh, Pierre, if you come to Pacificon, it would be amazing. Be sure to say hello, but I think you will. Montreal to San Francisco is nice. If I go MTL, okay, I'm not sure I get everything you say, sorry. The drive from San Francisco. Being Belgian, we definitely have very different definitions of long drive, so I'm not gonna answer that one. Oh, okay, Montreal. Okay, yeah. Maybe we should try to start fanning out the signals from the MCU. Okay, those are not placed correctly. This should be... well, mile doesn't change anything actually. This isn't connected. This is baseband RX. Audio mic. Oh. Okay. Hey, no. Okay, so this move out a bit. So this is the, oh yeah, this is the ferrite bead for the power supply, which is gonna come from I don't know where yet. And this is for here, so let's put it this way. This is ground, boot 0. Where does it connect to? Okay, there, okay. Escape button. Hi, Wojciech. Well, you don't hear me, but hello anyway. What's this music? Looks like I'm going to sleep. I'm not going to sleep yet. This is better. Okay, so yeah, routing the signals slowly. You will be there at M17 talk or booth at Pacific. Do we have a talk at Pacific? And I don't think we do. We will have a booth, that's for sure. It's gonna be next to... I don't remember all the names, but it's gonna be next to Cool Guys. And we will even have chairs, which I've heard is not always a given. Yeah, okay. Yeah, okay, I guess if you have no idea about it, it means that we don't really have any talk planned. We can talk at the booth, of course, as much as you want. Okay, so the way I imagine doing this is oh yeah, maybe we can't. It would be great if we could just like maybe swap some GPIOs on the MCU. Let me just ask this question to Silvano. He's the one in OpenRTX who wrote the code, I think, so he's gonna be able to answer me. Let me just read a few things. Okay. So this is the power button, which, yeah, it's gonna be routed, I guess, later on because it goes, yeah, okay. Power supply related and stuff like that, which is not routed yet. So here. Could the MCU move a bit to the left? I think yes. I think it would even be helpful if we do that. Yeah, we don't have much connected on this side, so we can clearly move it like this. Not gonna hurt. Okay, what's this weird? Okay. We are next to Hammer the outlet in Bishop Ranch Ballroom. Okay, that's possible. Oh yeah, Steve, you are definitely behind. So, hi, future Steve in 6 minutes. PTT in. Oh yeah, okay, it's connected right there. Yep, nope, sorry. Just need to remove the via and this. We have several sizes of tracks on the PCB, which I don't really like. How is it possible? Huh. Ah. Oh, okay. let's try to make it so that the tracks that are just like signal tracks or doesn't carry any currents use the net class settings. So basically I think I have deselected all the tracks that oh yeah, those, don't want to touch them now. And no, maybe I can just do track width. Use net class width. Okay. Smaller tracks for denser design. Oh yeah. Okay, that's so. Let's just move those two test points closer to where they will be, so that I don't have rat's nests going all around the screen. Okay, so those also need what's going on? Why is it not using the net class settings? While I just said right here, track use net class width via same thing, and that if you want, I don't really care. And it's definitely not using the net class value. I don't like this. What's going on? Track width is set to 0.15. Like, do I need to add? No, I don't think it would be. Ah, yeah, of course. Ah, better, much better. Okay, all right. Okay. Of course the LEDs are inverted, so we need to yeah. Well, actually, I think it would make more sense to have like power LED on the top, then PTT, then sync, and arrow at the bottom. So let's try to sub this. It's gonna make more sense, I think, visually, and also it's gonna be easier to route, so why bother? What's the distance between those? It's about 1.8, okay. Okay, let's try to align everything. Yep. Okay. Okay. LEDs have been moved. Of course, all the nets are now wrong. Can I like no? Yeah, let's not bother. Hey, again, it's the sleepy music. Go away. Sleepy music. Yeah, why not? Okay. Oh, we've been streaming for about an hour and a half now. Okay. Keeping time in mind. Oh, AOLED, come on, come on. Oh no, the VDD is not connected to a GPIO, so don't need that. Okay, maybe this can move up a bit. Okay, so we are now on the SPI bus for the OLED. This should be routed a bit more carefully, maybe. Okay, yeah, maybe let's try to do that. We still have this in the way, which I don't really know where to put. So this is cat. Would be better if it could stay on this layer, I think. What is this GPIO power? Oh, is it like the? Yeah, it's the pull down. Doesn't need to come here. It needs to go. I think it would be better if we put it here. We already have enough stuff around the MCU. And UART here. Of course it's gonna do that. Maybe we can have another layout for this. Oh, okay, we have the reference twice on this. Anyway, we have so many labels everywhere. It's just getting in the way, it's annoying. Is it called cat tx twice? Like, come on. Okay, now we are talking. Hi Bastien, how are you doing? Okay, now we should not put those too close to one another, the tracks RX and TX, otherwise we might get some crosstalk in between them, and we don't want that. So let's keep them slightly apart. Okay, I think this is quite good. Okay. Oh, those we can. Okay, what's this? VCap 2. Oh, it's for this pin. Okay. This one. Let's put the 10 nanofarad one closer to the MCU. Okay, just like this. Oh, we have the USB differential pair, which we will have to route. Maybe we can. Yeah, this is kind of a sensitive signal, so we might want to route that one carefully. Maybe I can. So now that this is routed, let's do like this. Like this. It's gonna get better over time. This differential routing. No, not this one. This one. Anyway, it's USB 2 speed, so it's not that critical. but yeah, this is the USB pair routed. Maybe, yeah, okay. We will do now the OLED, yes. SPI, Mozy, and SPI clock, and yeah, chip select. This can be routed later. It's not critical, but those two need to be routed carefully. We don't have any OLED MISO, I guess. We don't read anything from the screen. Let me check quickly. Nope, we don't. It's much better to route first the SPI signals, just because they are higher speed. They may generate more noise and be more sensitive to external noise if they are routed improperly. So yeah, let's just do that. We route them, and then the LEDs, which won't be moving quickly at all, we can then route them. Android kernel for that phone is open source. I do believe the Android kernel is open source anyway. Isn't it GPL licensed? So it has to be open source whenever there are any modifications in it. Which I don't even know if you are allowed to do modifications to the Android kernel and still publish it however you want. Or maybe, yeah, like, can you modify the Android kernel and still have the Google services and all on your device? I don't know. If you want to have a look at a nice phone, though a bit more expensive, the Fairphone 5 looks very nice. I mean, if I had to buy a phone now, I think that's what I would buy. Yeah, of course, the Pine phone, but it's like completely different kind of product too. I mean, if you want to have your bank application, your different bank apps on the phone, then Pine phone is out of the question, I think. Or maybe if you run some emulator and stuff like that, and even then it's gonna be like a massive pain to have it running properly, I think. Maybe I'm mistaken, which I would like to be mistaken on this one, but I don't know. I remember the OnePlus days where OnePlus was considered super cool because like it was running CyanogenMod and like you could reflash it, modify the ROM without losing the warranty, and everybody was kind of losing its mind about it. Me included, I have to say. I pretty much loved being able to reflash it and all, and second engine mode was pretty cool. But then now that you look at OnePlus, they have like their Oxygen OS thing, which is, well, some like it, some don't, but it's definitely not the same spirit as what it was when it first initially launched. Why does YouTube want me to listen at this sleepy music all the time, always the same music? Like, is it looping over the same 10 songs I haven't realized? Whatever happened to Ubuntu phone, yeah. This. GPL2, yeah, so if the Android kernel is GPL2, that means that if you modify the kernel, you have to. It's like, it's not, you may have, no, you have to release it as GPL2 code, so source code has to be accessible. So there is no non-open source Android kernel. If you do that, you break the law, basically. Which, yeah, big companies with money do that sometimes. Let's be honest. Okay, so this has to go all the way to the other side of the board. And it's the baseband signal, which means that it has to be as clean as possible, I guess. Where does it go to? Okay, so it goes to around here. Go through filters and then radio TX, which goes back to kind of good. Oh no, it's okay. Sorry. Oh, okay. So it goes here and then radio RX, and radio RX goes to basically the packet radio connector. Okay. Would it make more sense to have the packet radio connector be around there or not? because we have the cat, we have the radio, RX and TX, which goes here and wait, what? Radio TX. Oh yeah, it's just that we have a DC cap. I don't know. I squared C, where does it go? Oh yeah, potentiometer, of course. Mic mute here. No, I can do that. I have to go around here. So what is the mic net? Yeah, it's the signal from the microphone directly. So this one I would rather have it go all on the same layer to have it extra clean, to avoid amplifying garbage. And this one we can afford to have it go just gain, so it's not much. We can afford to have it go on the bottom layer for a while and then go up. This signal is for the reset of the microcontroller, so we can also afford to have it go around on the last layer. It's not that important. Okay, I don't have... So Bastien is not on Discord quacking me, so I guess it's just like is the song like quacking me with ducks in the song? Yes, Dan, that's pretty much it. It's like the old school TNC. Well, maybe I shouldn't say old school, I don't know who you are. It's like the TNC that we had in the time for AX25. It's basically this, but it doesn't take computer as an input. That doesn't really. It's just like audio input. Actually, I have like I do have one. It's not working. That's why I have it though. Even the reason I have it is because it was not working and I was supposed to try to fix it, and I kind of reached the conclusion that it's not very fixable. We don't know what the mistake is. We think it might be due to manufacturing error by JLC PCB. We are not sure, but this is what it looks like, the previous version. Basically, you have like this connector that you connect to your radio packet radio connector. So yeah, power USB, which you can use to update the firmware and provide power, of course. Here is the place for a small OLED screen, a few buttons to control the interface, volume, and this is the Kenwood connector that you use with these kind of Chinese speaker microphones. So you just have it like going here. And that's pretty much like just connected to your radio and to power, and this is how it works. There is no Vox capability, it's PTT only for now, I think. That would be, I think a Vox would be related to Vox would be related to the firmware. I think it would be feasible to edit in the firmware, but I'm not sure. You're welcome then. Yeah, I have a look here, and you see that microphone is not connected to the PTT, so microphone input, is amplified, goes here to the MCU, and then MCU does whatever it wants with it. So I guess you could add it. This is level shifting for PTT. I don't think it is. Yeah, it's definitely not in a good spot here. Let's move it. around here very quickly, which means that we have more space than I thought here. Well, not a big deal, we just have to be able to fit the power supply here, which this might be an issue, I don't know. Oh no! Need to just oh. Yes, FM repeater should work, I guess, except if it does have like any kind of tone squelch. If you have a tone squelch, this doesn't use it, so you should find a way to open the squelch of your repeater. Otherwise, yeah, I don't see why not. Well, of course you're gonna have the old hams in your area, which are gonna be annoyed because, as we all know, the old hams, which, you know, the one that do the police, are always annoyed by somebody experimenting in a hobby where you're supposed to have a license to experiment, basically. But this is another debate. Okay, what is this one? Oh, button down. So the deal would be to try to get those in order. Special repeater not normally used by public should be set aside for M17 work. So we already have M17 specific repeaters on the air. I am thinking about SR5MS, Sierra Romeo 5 Mike Sierra, I think, which is in Poland and maintained by Wojciech, which is an M17 repeater, not an FM repeater, but does use old FM gear, I think, to receive and transmit. Otherwise, we don't have yet an M17 repeater that you could use, that you could use like out of the box. I do believe it's possible that it might be coming at some point, basically. because we see that the M17 environment ecosystem, let's say, is evolving quite fast, actually. So I wouldn't be surprised to learn about an M17 repeater in like a year time. Okay, let's see how we deal with this mess. Not very pretty. Oh, so you think the Yaesu DR1X are not... We can't mod them anymore for the multi-modes? To turn them into a multi-mode repeater, Bastien? Okay, yeah, we will try to talk about that. Oh, firmware. Oh, damn. Well, I will see with ON6DP. I will see him Saturday, so I will see what he has to say. Well, it's not very pretty yet, but it looks like something. It should work. We still have the baseband signals, which those should be routed carefully too. You know what? It's past 10 PM already. I think I'm gonna stop here for tonight. And I also think that I'm gonna try routing a bit off stream, because it's not the most interesting part of the work. So I'd see to do that off stream. And if I have any big changes, big thing coming up, I will keep it for stream. Nice to hear that you liked it, Dan. Thank you for being here. Yeah, okay, let's leave it here for tonight. Well, thank you everyone for following along tonight. Well, tonight, European time, let's say. I hope you all enjoyed it. It was kind of relaxing, just routing slowly, calmly. Don't forget that we will be in Pacifican. Okay, let me just Pacifican 2023. Let's see. Okay, from the 20th to the 22nd of October. So yeah. If you are around or are hesitating still, please come, pay us a visit. It's not always that almost the whole M17 team is gonna be here. So I'm sure at least that Wojciech, Silvano from the OpenRTX team, and me will at least all be there in Pacifican. Steve, I think, will be here. Ed, I'm probably forgetting about people, but the Yanks will be there. Some Europeans too. And so, yeah, if you are there in the area or in the country, which I know it's big, but anyway, it's still closer than Europe. Take some time to pay us a visit. And see you next time. Take care, 73s, and bye-bye.